Today we are going to review sequences and series. First thing I'm going to do is number these formulas. So when we decide which one we're going to use, we'll just call them 1, 2, 3, 4, and 5. So these first two are for arithmetic and geometric sequences. The rest are for series, which means we're finding a sum. Arithmetic, geometric, and this is for an infinite series. For geometric, when r is between -1 and 1. So first, find the fourth term of a geometric sequence. Okay? So we're not finding a sum of a series, so it's none of these S formulas. And it's geometric, so it's going to be formula number 2. Okay, so a sub n. So we're looking for a sub 4 equals a sub 1, which is 2 times r, -4, times n minus 1, and we're looking for the fourth term, so that's 4 minus 1. So 2 times -4 raised to the third power is -128. 17th term, again, it's not a sum, so it's one of these first two. Arithmetic, so it's formula number 1. Okay, so we're looking for a sub 17. Given that the first term is 5, the common difference is 3, n is 17 minus 1. So that's 5 plus 3 times 16. The 17th term is 53. Find the sum of the first 4 terms. Okay, so sum means we're doing a series. It's going to be one of these 3. First 4 terms, number 5 is only for infinite. So it's either arithmetic 3 or geometric 4. So it looks like in the top we're multiplying by 4. So there's a common ratio of 4. In the denominator, it looks like it's staying the same, so we could say that there's a common ratio of 1. So it looks like there's a common ratio of 4, so it's geometric, so we're using the fourth formula. Okay, so S sub 4, the first 4 terms, equals the first term, 1/5, minus the first term, 1/5, times r, 4, to the n power, fourth power, over 1 minus r, so that's 1 minus 4. Okay, so I can do the numerator in parentheses, so 1/5 minus 1/5 times 4 to the fourth power. And I need to close parentheses on that numerator. Divided by 1 minus 4, which is -3, or I can do parentheses, 1 minus 4, close parentheses. And I get 17 for the sum of the first 4 terms. Sum of the first 24 terms. So once again, it's either formula 3 or formula 4 because it's a sum and it's not infinite. And it looks like we're going up 3 every time. So there's a common difference of 3. So I'm going to use formula 3. Okay, so the sum of a geometric or of an arithmetic sequence, n over 2 times a plus 1, or times a1 plus a sub n. Okay, so S sub 24 equals n over 2, 24 over 2, times the first term, -2, plus the last term, which means the 24th term. And I'm going to have to use formula 1 to find that. Anytime I'm using formula 3, I have to use formula 1 to fill in that last spot. So a sub 24 equals the first term plus the common difference times n, 24, minus 1. And what I get for that is going to go right there. So negative 2 plus 3 times 23. So 67 is the value of the 24th term. So now I can evaluate the sum of those 24 terms. 24 over 2 is 12 times negative 2 plus 67. 780 is the sum of the first 24 terms. Sum of the series, and that's for 5 and 6 both. Sum of an infinite series is formula 5, first term over 1 minus r, but only if there is an r that has an absolute value less than 1. Okay, so here it looks like the numerator is being doubled, so r is 2. Down here, we're multiplying by 5. Okay, so r is 2/5. So we can use formula 5 because r has an absolute value that is less than 1. Okay, so it's s sub n equals the first term, 1, over 1 minus r, 1 minus 2/5. So that's 1 over 3/5. Outer loop is 5. Inner loop is 3. The sum of that series is 5/3. Okay, I'm going to use formula 5 again for the sum of a series. In the numerator, it looks like we're multiplying by 4. In the denominator, multiplying by 2. So r is 4 over 2, which is 2. The absolute value of r in this case is not less than 1, so that means the sum has no limit.